Everyone, and welcome to our second video looking at IR spectra, where today we're going to be looking at matching up the IR spectra with some chemical structures. So this is really thinking about what is the spectra showing us and how does that fit with the possible compound structures that we might have. Okay, so here we have a spectra, and we've been given in this case 5 possible compounds that it may be. So the first thing I'm going to look at is have a look in that 3000 to 4000 wave number range on the left-hand side of the spectrum. And as you can see, there's really nothing at all there. So the next step is to have a look in that 16 to 1800 range. And if you look there, you can see a really nice peak here, sitting, I would say, somewhere around about 1730 to 1750 wave numbers. That would, to me, indicate that this is a carbonyl group and is probably, given the possible structures I've got, it's going to be either an aldehyde or a ketone. I have 2 possible structures that I've been provided with, 2-butanone and 2-methyl-propanol. So the next question is it an aldehyde or is it a ketone? What I'm going to do is I'm going to have a look at the carbon-hydrogen peak to see if there is a shoulder on the right-hand side of that at about 2750 wave numbers, and it turns out, yes, there is a shoulder peak there. So I'm going to be reasonably confident that this is an aldehyde rather than a ketone. And therefore, being an aldehyde, this must be 2-methyl-propanol. So let's have a look at our next spectrum. Here again, if we first off have a look in that 3000 to 4000 range, you'll see that again there's nothing really there that's of interest. If you have a look in that 16 to 1800 range, you will see a strong peak here at about 1715, 1720, which would again indicate a carbonyl group, probably, given the options I've got, either an aldehyde or a ketone. And as I have already identified the aldehyde and there's no shoulder peak there at about 2750 wave numbers, I would expect that this will be butanone. And so it is. Okay, so let's have a look at the third one. Now here, again, we're going to have a look in that 3000 to 4000 wave number range. And here we see a beautiful symmetrical parabolic peak here. That's suggesting to me that this is an alcohol. So the next thing to look at is to have a look in that 16 to 1800 wave number range. And although there's a couple of little tiny scrappy peaks up here, I don't think either of those is significant or obvious enough to be an alkene peak. There's certainly no carbonyl peak. So given the choices that I've got, the 2 alcohols I've got are cyclobutanol and 2-methyl-2-propanol. I'm pretty sure it's not the second option of those, 2-methyl-2-propanol, because there is no indication of a carbon-carbon double bond. In that case, I'm going to assume that this is cyclobutanol. You will also see here at about 1250 wave numbers, there is a peak which could indicate a carbon-oxygen bond as well. Okay, so next spectrum, spectrum D. So there's cyclobutanol. D, again, there is a beautifully clear parabolic peak at, in this case, about 3350 wave numbers. So that's indicative of an alcohol. Now the other thing we've got this time here is that it's about 1680. There is a medium-sized peak, quite a narrow one, and that to me would be indicative of a carbon-carbon double bond. Therefore, given the range of options that I've got, I'm going to assume that this is the spectrum for 2-methyl-2-propanol. And so it is. So we come to our final structure. Obviously, as a process of elimination, you might say this is obviously going to be our ethyl vinyl ether. But let's actually have a look at what we've got as well. This one's a little bit harder. We've got this peak here at about 1620-ish. It's pretty ugly, but I would have to assume that's a carbon-carbon double bond peak purely because of where it's sitting in the spectrum. There is also a peak at about 1200 wave numbers, which could easily be a carbon-oxygen stretch. And so the indications point towards this being ethyl vinyl ether. And so it is most likely to be. However, this one's not as clear-cut as some of the others. Luckily, ethers are not likely to be assessed in this assessment. Okay, so that's a very, very brief rundown on the sorts of thought processes that you might think through with trying to match up spectra with structures. Quite often you won't actually have this list of structures to match to. You'll simply have the spectra and whatever information you've gotten from your other spectra as well. But I hope you start to see how you're looking for the different types of peaks. I'll see you in the next video where we start putting together NMR and IR spectra to actually start coming up with some really detailed information. I'll see you then.